So what you need to be able to demonstrate to us at the end basically of this, I hate to call it a unit, but this PBL number 2, or even before the end of the PBL, honestly, is the understanding of these principles here. And it all comes down to math modeling and predicting. In terms of energy, okay, we have potential energy, which is, you will learn, the mass times the acceleration due to gravity times the distance the object falls, and that's potential energy due to gravity. We'll also have kinetic energy, which is going to be 1/2 the mass of an object times the velocity squared. And then we're going to have work, which is going to be equal to force applied on an object times the distance that the force is applied. And then you're going to have power equations, which will help us equate stuff. And the power is going to come in handy really when you start producing some final things. But that's the amount of energy used per second. Okay, so all of these equations you're going to be using in describing forces in motion. Which leads us to another one. Force is equal to mass times acceleration. Which leads us to these statements up here that you're just going to have to get a handle on. Most of the time we start at the bottom, and acceleration is caused by forces. Alright? And forces applied over a distance is work that is done. And to do work you need energy. Okay? So if we have a little, I don't know, save you pop bottle cap resting on a table, right? And if I can't draw a hand very well here, but say you have your finger and you flick the bottle cap with your finger, right? And, well, you're applying a force and you're using energy at the same time. And so this bottle cap, if it has an initial velocity equal to 0, you know if you flip it, okay, if you apply a force in this direction, the bottle cap is going to slide a certain distance, right? And so its initial velocity is 0, and then it actually gets some velocity, doesn't it? Okay, the velocity changes. Well, that's the change in motion, is when that velocity changes. That's a type of acceleration. You go from 0, it starts to accelerate because you applied some sort of force with your finger. All right? So your final assessment will be being able to show that you can apply these equations in 2 different ways. One is making a prediction, okay? Making a prediction, you could say, well, if 100 joules of energy are applied to a certain object, to like 1 gram cap, well, what amount will it accelerate? That's one way you can be assessed, is just a simple prediction. And then what you'll be doing is filming it, okay, and using tracker. So that's another thing we can do, is test your ability to use and apply all these things with this tracker program. And in tracker you can film an object, right? And then you can collect the velocity and position data from tracker, and then using the data to determine forces applied. Okay, so there's different ways we can do this. Is you can actually accelerate something and apply tracker to figure out how much energy and force was applied, or there's the more traditional prediction method where you give a question and you say, how much would it accelerate if you did this? And so you can kind of use both different methods. This will make more sense once you get a better handle on these relationships here and the math equations that we'll be using here. Okay? Hope that's all right. Bye.